Now we'll discuss joint probability. The joint probability between any input symbol AI and any output symbol Bj is given by the joint probability. What is meant by the joint probability? P of AI Bj. P of AI Bj P of AI Bj equal to P of AI intersection with Bj. P of AI intersection with Bj, that is equal to P of Bj divided by AI, P of AI. Joint AI and Bj, we call it as joint probability. Okay, P of AI comma Bj equal to P of AI intersection with Bj, that is equal to P of Bj divided by AI, P of AI, that is equal to P of AI Bj, P of Bj, vice versa. Okay, when we multiply all the elements of the first row of channel matrix of equation number 3.1 by P of A1 and second row by P of A2 and rth row by P of AR. See here, in the channel matrix, okay, here we have the conditional probability P of B1 A1, P of B2 A1, PS A1 up to here. Here, this condition probability is multiplied by P of A1. Here also P of A2, P of A3, P of AR, and so on. Okay, channel matrix is multiplied by P of A, P of A. Okay, here the first row multiplied by P of A1, second row P of A2, and third row P of A3, and so on up to P of AR. Last row is multiplied by P of AR. Okay, here, what is this? This one is joint probability. This one is called as joint probability. P of AI Bj, P of A1 B1, this one, P of A1 B2, P of A1 BS, A2 B1, A2 B2. If what is the joint probability of P of A2 B2? P of B2 divided by A2, P of A2. Like that you can write it. Okay, this is the joint probability matrix. See here, using equation number 3.14 in 3.15. See here, in this 3.14, what is 3.14 here? P of AI Bj. AI Bj. If A is 1, J is 1, A1 B1. P of A1 B1 equal to P of B1 divided by A1, P of A1. See here, P of B1 A1, P of B2 A1, P of BS A1, and so on. Okay, then here, that is joint probability. Using equation 3.14 in 3.15, we get P of AI Bj or P of A comma B. Okay, left side row wise A1, column wise B1, B2, BS in outputs. Yeah, input symbols. P of A1 B1, P of A1 B2, P of A1 BS, A2 B1. That means condition probability. This is the joint probability of P of, what is the P of A2 divided by A2 B1? P of A2 B1 is P of B1 divided by A2, P of A2. See here. This. So it is called as P of A2 B1. A2 B2, P of A2 B2. That means P of B2 divided by A2, P of A2. That is the conditional joint probability. Okay, this is the, see here, the matrix of 3.16, this one, whose elements are the various joint probabilities between input and output symbols. Okay, this P of A1 B1, we call it as joint probability matrix. Okay, what is conditional probability? The elements of conditional probabilities matrix is called as channel matrix. P of B1 A1, P of B2 A2, sorry, P of B2 A1, P of B3 A1. That is called as channel matrix. Here the elements are joint probabilities. So that's why this matrix is called as joint probability matrix, popularly written as JPM. What is JPM here? Joint probability matrix. The same denoted by P of AI, Bj or P of AB. The JPM has very interesting properties which are quite useful. Here we will discuss some properties of joint probability matrix JPM. What is the first probability? The property 1, from the first equation of 3.12. First equation of equation 3.12. What is the first equation? P of B1. What is P of B1? Yeah. This one. P of B1 divided by A1. P of A1 plus P of B1 divided by A2. P of A2. Okay. This is the condition probability, joint probability. This is also joint probability. This is also joint probability. Okay. The P of B1 equal to, check it. What is P of B1? P of B1 equal to P of B1 divided by A1, P of A1 plus P of B1 divided by A2, P of A2. Okay. P of B1 divided by A, P of AR. Okay. Check these elements. First element, P of B1 A1, P of A1, where it is? P of B1 divided by A1, P of A1. Okay. Next, P of B1 divided by A2, P of A2, where it is? P of B1 divided by A2, P of A2. Then third term, so in that only, P of B3, P of B3 divided by, P of B1 divided by A3, P of A3, see here, it's in here, and so on, P of B1 divided by here. See, the sum of first column elements of the JPM, joint probability matrix, are what? Probability of the first output. Second output you can consider P of B2 A1, P of A1 plus P of B2 A2 multiplied with P of A2 and so on, P of B2 divided by A, P of AR. See here, what is that? The output, second output probability is equal to sum of these elements. These elements are second column of the JPM. See, second elements of the JPM. P of B2 divided by A1, P of A1, P of B2 divided by A2, P of A2, P of B2 divided by A, P of AR. Okay, the sum of second column of the elements in matrix, JPM matrix, are P of B2, probability of second output. Similarly, the column 3, and the sum of all the elements, the column 3 are P of B3. Similarly, and so on. That's why the first property, this one, P of B1. Okay, these joint, we write this one as P of A1 B1, A2 B1, AR B1. These joint probabilities of RHS of this equation, this 3.8, are observed to be present in the first column of the JPM of equation 3.16. Those are the first column elements, some of the first column elements. Similarly, okay, that is, see here, 3.16. Hence, we can conclude that by adding all the elements of the first column, we get the probability of first output symbol B1. Yeah, how we will get the output probability? By adding the column elements of the JPM. We will get the output probability. Similarly, P of B2. See here. P of A1 B2, P of A2 B2, P of and so on. So similarly, P of BS. From equation 3.18 to 3.20, we can derive the first property of JPM. What is that? By adding the elements of JPM column wise, we can obtain the probability of output symbols. Therefore, summation of I equal to 1 to R, P of AI Bj equal to P of Bj. Just remember what is P of Bj? Okay, we already derived those equations. Okay, next, property of 2. Using the theorem of total probability for the input symbols. Similarly, we can use the theorem of total probability for input symbols. P of A1. P of A1 equal to P of A1 B1, A1 divided by B1, P of B1 plus P of A1 divided by B2, P of B2 plus and so on, P of A1 divided by Bs, P of Bs. Okay, P of A1 equal to, this is P of A1 B1, A1 B2, A1 Bs. These P of A1 B1, P of A1 B2, P of A1 Bs. Check it in the joint probability matrix. P of A, this one is A1 B1. I'll check it here. A1 B1, A1 B2, A1 Bs. Those are row elements, right? Then, okay, these joint probabilities of RHS of equations 3.222, 3.24, 3.222, 3.24 are observed to be present in the successive rows of matrix of equation 3.16. Hence, we have second property of JPM as, by adding the elements of JPM row wise, by adding the elements of JPM row wise, we can obtain the probability of input symbols. Okay, what we will get here? By adding the elements of JPM row wise, we can obtain the probability of input symbols. This property can also be expressed as J equal to 1 to S. J equal to 1 to S. Okay, here I is constant, J is varied. Here in property 1, J is constant, I is varied. Remember, I is index for inputs, J is index for outputs. J equal to 1 to S, P of AI Bj equal to P of AI. Okay, property 3. By adding equation 3.2 to 3.24. Which one? 3.2 to 3.24. You can add it. P of A1 plus P of A2 plus P of AR, that is equal to P of A1 B1, A1 B2 up to sum of P of A1 Bs. Similarly, P of A2, P of A2 B1 plus P of A2 B2 plus and so on up to P of A2 Bs and so on. At last, P of AR, P of AR B1 plus P of AR B2 plus P of AR Bs. So here, which covers all the elements of JPM. These first row elements, these are second row elements, these are last row elements, right? Okay, by adding all the row elements, okay, all the elements of the JPM. See here, the LHS of equation 3.26 equal to 1 from equation number 3.11. From equation number 3.11. What is the 3.11 equation? Here to return summation P of A1 plus P of A2 plus P of AR equal to 1. So what is P of A1? Okay, those are the first row elements. Sum of first row elements of the JPM. P of A2, sum of second row elements. Okay, by adding all the elements of JPM, it's equal to 1 from equation number 3.11. That's why the property 3 is, what is the property 3? The sum of all the elements of JPM is equal to unity. Okay, this is expressed as summation of I equal to 1 to R, J equal to 1 to S. Summation of I equal to 1 to R, summation of J equal to 1 to S, P of AI Bj equal to 1, which covers the sum of all the elements of JPM are equal to 1. This is also very, very important. Okay. Now we'll discuss the problem. In a communication system, a transmitter has 3 input symbols, A equal to A1, A2, A3. And receiver also has 3 output symbols, B equal to B1, B2, A3. Okay, the matrix given below shows JPM with some marginal probabilities. See here, 1 divided by 2, this is P of A1, B1. Okay, P of A1, B2 not given, it's unknown values. P of N1, A1, B3, 5 divided by 36. A2, P of A2, B1, 5 divided by 36. P of A2, B2, 1 divided by 9. P of A2, B3, 5 divided by 36. Okay, P of A3, B1, no, we don't know, it's unknown value. P of A3, B2, 1 divided by 6. P of A3, B3, unknown value. And also he given the sum of first row elements is equal to probability of first output symbol, that is 1 divided by 3 he given. 14 divided by 36, second output probability, and third unknown value, third output probability unknown. Okay, find the missing probabilities, that is star means missing probability in the table. Then find P of B3 divided by A1 and P of A1 B3. And third one, are the events A1 and B1 statistically independent? Okay, first one. Here, in first column, the third element, third row, first element is unknown value. Yeah, we know that from the property 1. What is the property 1? The sum of, okay, column elements of the JPM are equal to probability, output probability. Okay, that's why 1 divided by 12 plus 5 divided by 36 plus unknown value equal to 1 divided by 3. See here, addition of RHS of equations 3.18 to 3.20 also yields all the elements of JPM which add up to unity. Here we know that when we add the, okay, output probability, input probability also 1. Okay, when we add the P of B1, B2, B3 and so on up to Bs, it's also equal to 1. Okay, here we know that J equal to 1 to 3, J equal to 1 to 3 is equal to P of Bj, that is equal to P of B1 plus P of B2 plus P of B3 equal to 1. Okay, but he find out this one, this unknown value, this 1 divided by 3, 14 divided by 36, this P of B3 is unknown value. We know that the sum of output probability is equal to 1. That's why P of B1 is 1 divided by 3 plus P of B2 is 14 divided by 36 plus P of B3 is unknown, that is equal to 1. P of B3 is equal to, after substituting, we will get 5 divided by 18. Here, what is the value here? 5 divided by